Alright, so in 8.1 and 8.2 we were learning about sequences in series. 8.3 is the same stuff, but we're learning about a different type of sequence in series, which is going to be geometric. So a little bit different than what we've been doing before. So in identifying a geometric sequence, the ratio of any term to the previous term is constant. This constant ratio is called a common ratio, and it's denoted by R. So in a geometric sequence, we are multiplying to get from one term to the other. So we are multiplying by one constant number. So the difference between geometric and arithmetic, which was what we did in 8.2, in an arithmetic sequence, we are adding the same number each time. In geometric, we are multiplying the same number. So tell whether each sequence is geometric. What do we have to multiply to get from 16 to 12? 2. Do we multiply 2 times 12 and get 20? Nope. So is this first one geometric? No, because we're not multiplying by the same number each time. So not geometric. B is a little bit different. We see that our numbers are getting smaller, but we're still multiplying. We're just multiplying by a fraction. So what are we multiplying by? 1/6. Not 1/6, close. Maybe if you look at like the smaller numbers over here, that'll give you a clue. 1/4, perfect. So we're multiplying by 1/4, multiplying by 1/4, and multiplying by 1/4. So is the second one geometric?
Yes.
Yes. And what's our common ratio? 1/4. Any questions on this page? All right, we got 3 more examples just like those. So what are we multiplying to get from 27 to 9? 1/3. Does that work for 9/3? I mean 9, if we multiply 9 by 1/3, do we get 3? Yes, so we're multiplying by 1/3. What about from 3 to 1?
Yeah.
Yep. And from 1 to 1/3? Yep. So is this geometric?
Yeah.
Yes. And what's our common ratio?
1/3.
1/3. Number 2. What do we multiply to get from 2 to 6? 3. If we multiply 3 times 6, do we get 24?
No.
Nope. So is this geometric? Nope. And number 3, what do we multiply by -1 to get +2? -2. What about 2 to -4? -2, and -2, and -2. So is this geometric? Yes. And what's our common ratio? Common ratio is -2. Perfect. Any questions here? All right. So next we're going to be writing a rule for a geometric sequence. So the nth term given by a geometric sequence with first term a sub 1 and common ratio r is given by this. So this is our formula to find the rule for a geometric sequence. Once we find our rule, so this formula, plug in everything we need, then we can find any term of our sequence that we need. We can find the 100th term, the 1000th term. Here, since we're multiplying by a constant number, it would be a really, really big number, but we could definitely still do it. A sub 1 is our first term. First term. R is our common ratio. And N is our number of term. And a quick way to find R is we divide the second term by the first term. So whenever it tells us that it's a geometric sequence, to find R, we just take the second term and divide it by the first one. Alright, so let's look at example 2a. Write the rule for the nth term of the sequence, then find a sub 8. So first we want to find our general rule. So we need to find our common ratio and our first term. So how do we find the common ratio? Divide the second by the first. So 15 divided by 5. What's 15 divided by 5? 3 over 1, which is just 3. So we're multiplying by 3, multiplying by 3, multiplying by 3 each time. So 3 is our common ratio. What is our a sub 1? 5, our first term, which is 5. Now we plug everything in. So a sub n is equal to a sub 1, which is 5, times r to the power of n minus 1. This is our general rule. So if it asks you for the rule, that is this equation here. Now it asks us to find a sub 8, so we're going to plug in 8 for n. So we have 5 times 3 to the power of 8 minus 1. From here, just make sure you're following your order of operations. What do we have to do first? Subtract in our exponent. So 8 minus 1 would give us 7. What do we have to do next? 3 to the 7th power. So 3 to the 7th power would be 2,187. And then we multiply that times 5. So we get 10,935. That's our 8th term. Any questions here? So B. First thing we want to do is find our common ratio. How do we find the common ratio? Second term divided by the first term. How do we simplify negative 44 divided by 88? Negative 1 over 2. So that's our R. We're multiplying each one of these by negative 1 over 2 to get to our next term. And what is our a sub 1? 88. So we have a sub n is equal to a sub 1 times r to the power of n minus 1. This is our general rule. Now we need to find our 8th term. So a sub 8 is equal to 88 times negative 1 over 2 to the power of 8 minus 1. So a sub 8 is equal to 88 times negative 1/2 to the power of 7. What should we do next? Negative 1/2 to the power of 7. Which would be negative 1 over 128. So a sub 8 is equal to negative 88 over 128. And we can simplify this a bit. Let's see, 4 goes into both of them. This would be 22 times and 32 times. 2 goes into both of them again, so 11 over 16. And that's as much as we can go. For these types of questions where your answer is going to be a fraction, on a test or quiz, it'll either tell you to leave it as a fraction or as a decimal, or if it gives you fractions in your sequence here, you have to have fractions in your answer. So for this one, it doesn't matter because it doesn't tell us what we have to do. It also doesn't give us fractions or decimals in our sequence. So we could either leave it as a fraction or a decimal. So the decimal would be negative 0.6875. So either one of these would work. Alright, let's take a look at number 4. Write a rule for the nth term of the sequence, find a sub 9. So first thing we want to do is find r. How do we find r? What's our common ratio? Second term divided by the first one, so 15 divided by 3. What's 15 divided by 3? 5. So our common ratio is 5. We multiply by 5 each time to get to the next number. What is our a sub 1? 3. So we have a sub n is equal to a sub 1 times r to the power of n minus 1. This is our general rule. Now it asks us to find a sub 9, so we're going to plug in 9. What do we have to do first? 9 minus 1, which is 8. Then we want to do 5 to the 8th power, which is 3 times 390,625. And then we multiply that times 3. So a sub 9 is equal to 1,171,875.